So what makes this particularly good? What's the analysis of this? Well, this is an n log n algorithm, believe it or not, even though that seemed a bit complicated. But this is why. So we're going to go ahead and mix this up again. We are going to go ahead and now, rather than doing the left half and the right half, basically, and do the left left and then the right left and the right left and and rather than doing that, I'm just going to split them up. I'm going to take this list, I'm going to split it up into two lists, two unsorted lists of size 4. Then we're going to split it up into lists of size 2, right? And then we're going to take these and split them into lists of 1s. Right? Let's go ahead and make some more room. So we've kind of split this up into 8 lists of 1. Right? So the way merge sort is going to work is that we are going to go ahead and we are going to start combining these lists. So we've got 8 lists of 1. So now we're going to take this pair and we're going to merge them together into a sorted list of size 2. We're going to take this pair and merge it together into a sorted list of size 2. And same for each of these, and they just all happen to be right in kind of the correct order for that. Now for this, then we're going to go ahead and take these lists of size 2 and merge them into a sorted list. So a sorted list of size 4. Take this list and merge it into a sorted list of size 4. Now this isn't the order the computer is going to do it in, but it's good but doing it this way is useful for understanding the runtime. So we've got 2 sorted lists of size 4. Now we need to sort these sorted lists of size 4 into a sorted list of size 8. So that's smaller. That's smaller, that's smaller, that's smaller, 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 smaller. So we've sorted that list. So how many operations did that take? There were 8 items. So how many operations did I do? Well, all right, if there's n items, then what did I have to do? Well, I took this list of size 8 and I broke them into 2 size 4 lists, which is a total of 8 items. Then I took those size 4s, right, and I further broke those into size 2, into 4 lists of size 2, so 8 items total again. And then I split them into size 1s, right, for a grand total. So we basically did 3 splits there. So we had like 3 levels of splits. Right? And the splitting doesn't take too much time, actually, right? It's just simply moving items around. Okay, so now let's consider we've got 8 items. They're going to get merged together. Not all going to get merged together at once on this bottom layer, but we're merging 2 items of size 1, right? We're merging 2 items of size 1. Okay, so that was to get 4 sorted lists of 2, that was 8 operations. Okay, now we need to get 2 sorted lists of 4, which also will take 8 operations total for that entire recursive level, right? And then finally, to take 4 and merge them into 2 4s and merge them into a single 8. Again, we're moving 8 items around, right? 1, 2, 3, 4, 5, 6, 7, 8, right? To get a single sorted list. So what is the runtime for this? Well, it's n log n, right? Because at each level of recursion, we're going to be merging n items together into sorted lists or sorted sublists, right? And then a merge operation over n items, right? No matter how many sublists or lists there are, right? There's going to be n items that are operated over. Okay, so how many layers did we do? Well, it got split into half once, twice, and then 3 times. So there were 3 merge layers to bring it back together, right? And 3 is log base 2 of 8. So that's that relationship. So, and if you think about it, right, on the definition that I've gone over for logarithms, right, I'm splitting this into halves until I can't split it into half anymore. So what did I say that relationship was? Well, log base 2 of n is the number of times I can split something into halves before I can't split it into halves anymore. So that's why this operation is n log n, because basically I have n items to merge together, and I have so I have n items to merge together, and how many times do I do this merge operation at different levels, right? Well, I do it once for each time. Basically, it's been split in half until I got all the way to sublists of 1. So what is the space requirements for this? Well, the space requirements for this the disadvantage is that actually doing an in-place merge is not really something that you can really do with array lists. But if we're working on linked lists, then it's pretty straightforward to do because you're just moving nodes around. So this merge sort is kind of really optimal for when you're sorting linked lists, because the merge operation doesn't require any extra space. But if you're trying to merge 2 arrays or 2 array lists, you need extra space to do that. So that's what makes this a bit tricky. So it uses extra space to do it. But the advantage is that this is always n log n. Best case, worst case scenario. Average case scenario, also n log n. So let's go through one more example through this if you didn't quite get this. And I'm going to go ahead and just do it with the disks this time. Right? So I'm going to go ahead and split this up. Right? And I'm always going to make it so that if there's an uneven amount, the right half is going to lose out on getting an item. So we split. So let's take a look. Right? I've got these 7 items. I split it into 2 sorted lists to 2 unsorted lists. Right? A left and a right. So now I need to merge sort the left. To merge sort the left, I have to merge sort the left and the right of it. All right? And to merge sort the left, I've got to merge sort the left and right. Now these 2 things are size 1, so we can merge them together pretty easily. So now I've got to merge sort this right half, split it up into 2. So I merge sort the left, merge sort the right. Those are the base cases because they're size 1. They're automatically sorted, so I can merge them together. And now I can merge these 2 sorted lists of size 2 together. Awesome. So now I've completely sorted the left half of that. Now to sort the right half, I've got to split it up. Now to sort this side, I have to split this up some more. So I need so now I've got 2 sorted lists of size 1 to merge them together. Just merge them together into sorted list of size 2. I'm done over here because that's size 1. So now merge together, and now I can merge together the whole thing. And we're done.